last session, I explained about three important memory mapped register, that is pin select 1, pin select 2 and pin select 0. In this session, I'll be explaining about these important memory mapped IO registers, that is input output direction, input output set, input output clear and input output pin value register. Okay, let's see what these are and what exactly they do. Okay, so the very first thing you should know is what exactly do you mean by memory mapped IO register. Memory mapped IO register is a special hardware register that has fixed memory address and is used to control or read hardware by using normal memory read write instructions. Okay, that is using simple LDR or STR instructions, we can modify the content of that particular memory addresses associated with these specific registers. Through that, we are easily able to control or read the hardware. Let's understand them in detail. I have written X here because it can either be IO0DIR or IO1DIR. Same thing applies to all these registers because the 0 or 1 here determines whether we are speaking about port 0 or port 1. Okay, now that we know what exactly this X means here, let's understand its functionality better. First thing you should know is these are all IO, that is input output registers. Either we are setting the direction, the values or checking the values. Okay, all of this will become important when we are discussing the GPIO, that is general purpose input output functionality. Only if we choose pin select bits in such a way that the functionality of a particular pin is chosen to be general purpose input output, these registers become important. So let's move ahead with the assumption that we have set all port 0, all pins as GPIO pins. Okay, by setting all pin select value as 0. Okay, then we can come here and we can check how exactly to set or clear the values of those pins. The first thing we have to do is nothing but set the direction. That is, when you call a pin as GPIO pin, it can act as input or output. Whether a particular pin should act as input or output is determined by this IOxDIR register, that is input output direction register. In our previous assumption, we considered port 0 to have all its pin set as GPIO pin. So we'll assume here we are considering IO0DIR. Okay, and if we are discussing about port 1, it would be IO1DIR. Okay, so what happens in this particular case is, based on which particular pin you set as 1 and which particular pin you set as 0, a particular GPIO pin is declared to be either input or output pin. Or if you declare a particular pin as 1, it will start acting as output pin, and if you declare a particular pin as 0, it will start acting as a input pin. Okay, that's what we are doing here. The last here, the tick marks indicate the value to be 1 and blank indicates the value to be 0. This is nothing but a screenshot of the peripheral simulation that we can check during debugging. And in this particular case, the last 8 bits, that is the least significant byte, is set as 1 so that they act as output pin, while the remaining bits are set as 0 so that they act as input pin. Okay, so this would be something like F, EF and all zeros. Okay, this is the value set in the IO direction register. Let me consider this is my microcontroller. In our case, it is nothing but LPC2148. This is some peripheral device. It doesn't matter what exact device it is. See, you know that this microcontroller should be connected to the peripheral through some pins, correct? So, if you want to send some signal to the peripheral from the microcontroller, you will need output pins. To receive signal from the peripheral, you will need some input pins. Correct? So now I am declaring the last 8 bits of input output direction register as 1, which clearly means I want the last 8 pins to act as output pins. Once I have declared them as output pins, I can send the value, either I can send zeros or I can send 1 as the information from the microcontroller to the peripheral. So the next thing I notice here is IO0 and IO0 If you want to set the output pins as high, then you will be using IOxSET, that is IO0 or IO1 set. While if you want to clear the output, that is if you want to set output pins as low, you will be using IOxCLR register. One thing you should know in both the case, if you write a value 0 anywhere in any bit position, that is not going to affect the output. That is, if I am sending a value IO0 set all zeros and dB, only the output pins get affected in these positions, that is in position 0, 1, 3, 4, 6, 7. Okay, other positions here starting from 31 to 8, and if you consider pin number 5, pin number 2, these will retain its previous values. Similarly, if I consider IOxCLR, I am writing all zeros here, so nothing gets affected. But if in case I change this, okay, and I write something like 1 here, immediately IOxSET register content also gets modified, something like this, and at the same time output will also change, that is whichever position of IO0 I have set my pin, okay, that particular bit position output will get cleared. Okay, if you check in Keil simulator, this will always have a value 0. That is because as soon as you write a value 1, instantly it clears the set bit, clears the output, okay, and retains the value of all zeros. And next what we have is IOxPIN. This particular register is used to know the status of your pins, or in other words, to reflect the current logic level of all pins of a GPIO port, whether currently specific pins are having value 1 or 0 is determined by reading the content of IOxPIN, that is it could be IO0 or IO1. This always shows the exact value that is seen by the CPU. Okay, we know all these are 32-bit registers, but one thing that you should focus here is in this particular case, each bit are used to either control specific pin, that is one particular pin, or to show the status of that particular pin. But if you consider the pin select register, that 2 bits were used to control one particular pin. So those were few things you needed to know about these important memory mapped IO registers. Okay.